Hi, in today's video I would like to introduce you a very nice problem of Canadian Mathematical Olympiad edition 1992, question number 1. Here is the following setup. Prove n factorial is divisible by this sum as I goes from 1 to the n if and only if n plus 1 is not and not prime. Okay, it seems very confusing question. So another thing here, we say in n factorial is divisible by this sum, that's mean n factorial is bigger than this one. Okay, I'm going to give the following hints in order to solve this problem. So here is the following hints. We say in a capital A is divisible by capital B, implies B must be inferior or equal to capital A. Okay, so I'm replacing the capital B with this sum because I believe this sum is inferior or equal to this product. Okay, because the sum of these terms, if you take a look, is always inferior of the product of these terms. If you transfer the sum of these numbers into the product and those numbers are bigger or equal to 1, is giving you the bigger value. Always when you comparing the sum and product with the same numbers, is always giving you the big number. Okay, that's what happened here. So the second hint, I'm going to use this standard basic formula for the sum as I goes from 1 to the n of I equal to 1 plus 2 all the way down to the n equal to this product. N is multiplied by n plus 1 is divided by 2. So go ahead, pause this video if you would like to give that try to this problem. When you are, come back to see the full solution. Okay, let's get into the solution. I'm going to prove this second hint. So I have the sum of I as I goes from 1 to the n equal to 1 plus 2 plus 3 and all the way down to the n. Okay, I'm going to rewrite the same sum in the backwards. So I will get the sum as I goes from 1 to the n of I equal to n plus n minus 1 plus n minus 2 and all the way down to 3 plus 2 plus 1. Okay, I'm going to make the sum of this. I will get 2 times this sum as I goes from 1 to the n of I. So the technique that I'm going to use here, I'm going to put the first term in the first expression with the last term in the second expression, and so on and so forth until you get the last term. Okay, so now I'm putting 1 plus n. For the second term, I'm putting 2 plus n minus 1. Okay, I'm separating all the terms individually. So I will get, for the third term, I will get 3 plus n minus 2 and all the way down to the n minus 1 plus number 2 plus the last term n plus 1. Okay, I will get 1 plus n here. 3 minus 2 equal to 1, that's mean 1 plus n. For this term n minus 1 plus this number 2, I will get n plus 1 as well. For the last term, I will get n plus 1. So that's mean n times is multiplied by 1 plus n. Okay, I will get 2 is multiplied by this sum as I goes from 1 to the n of I equal to n time is multiplied by 1 plus n. Okay, so by dividing both sides by 2, I will get this expression. So I have proven this one. So let's move on to our question. Previously we have shown this statement is true for all integer n bigger or equal to number 1. Okay, this sum as I goes from 1 to the n of I which equal to n is multiplied by n plus 1 is divided by number 2 is always inferior or equal to n factorial. Okay, which equals to 1 is multiplied by 2 is multiplied by 3 and all the way down to the n minus 1 and is multiplied by the last term which is n. Okay, now it's very clear here, this one is inferior or equal to this one because always the sum of the terms, if n is superior or equal to number 1, the product become larger than the sum of these terms. Okay, since the condition says n plus 1 must be even, this is even, Now we are going to cancel n from both sides. Okay, that's mean 2 is divide n plus 1. Okay, in addition, here is the point. After the division of n plus 1 and number 2, okay, is giving us a number. That number, it could be odd or even. If is odd, it will be simplified by those numbers that we have here in this product, okay, because here is a package of the numbers, even odd, even primes numbers, okay. So whatever you have here will be cancelled by this product as an n factorial, okay. So now if n plus 1 is divided by 2 is an even, it will be n plus 1 divide n minus 1 factorial, because if n plus 1 is divided by 2 is an odd, that's mean n plus 1 is divided by 2, n plus 1 over 2 is divide n minus 1 factorial, okay, because as we said this result is even, that's mean will be divide this one, because n factorial is a component of odd, even and primes numbers, okay. So whatever comes here, whatever the result is, you will be divided by those numbers which have in this n factorial, okay. Finally, this sum, as I goes from 1 to the n, divide n factorial. In the other word, n factorial is divisible by this sum. I have proven this one. If you are interested in watching this one, don't forget to support us with your like and subscribe. Thank you for watching. I will see you in next video. Bye.